Welcome to another section where you will learn everything about data visualization. Before we move to various techniques that are used to visualize data, let's see what data visualization is. Data visualization refers to the graphical representation of data by using visual elements. The element may be a chart or infographics, and sometimes you may also want to visualize your data by using maps. There's a story behind every data, and data visualization brings this into life. It enables decision makers to see the data analytics presented visually so that they can understand the difficult concept and see the hidden pattern. According to the English adage, a picture is worth a thousand words because our eyes are easily drawn to color and pattern. Data visualization helps us to grab the reader's interest and keep their eyes on the important message of the data. Why do we need to visualize our data? There are many reasons why we may want to visualize our data. Number one is that it's a powerful way to explore our data, and that is what is called exploratory data analysis. It displays the summary of our data at a glance. We can easily see the summary of our data when we visualize data sets. We can also use charts and graphs, which make it easier to identify patterns and trends. Another reason why we may want to visualize our data is that it identifies areas that need attention or improvement. One thing is that people don't really understand what we are presenting by using table, except we visualize it. As we said it before, that a picture is more than 1,000 words. Before you visualize your data, there are important 5 questions that you must ask yourself. You must ask yourself whether you want to see the relationship between two or more variables, or do you want to understand the distribution of the data set, or looking for any outliers. Outliers are extreme value. It may be a value above other values or a value below other values. Sometimes they call it unusual data point. The third question to ask yourself when you are visualizing data is that, am I looking to compare multiple values or looking to analyze a single value over a time? That is where you can now see whether you want to use a line chart to show how the pattern is going over a time. And that is what is called a trend. The fourth question that you may want to ask yourself when you are visualizing data is that, am I interested in analyzing trend in my data set? Why the last but not the least is that, is this visualization an important part of my data story? Because sometimes maybe a single value can easily present the data point. That is why this question is now coming into life, whether you want to use that kind of visualization as part of your storytelling. One of the data visualization techniques that you can use to present your data is a bar chart. A bar chart is one of the simple techniques that one can use to visualize any categorical data. For example, here now, we have a categorical variable called species. And in that species, we have 3 levels, which are Adelie, Gentoo, and Chinstrap. As you can see here, the bar represents how many times such species appear in your data set. Now you can see that Adelie appear around 145 times, while Gentoo appear around 120 times, while Chinstrap also appear around 60 times. One thing about a bar chart is that it has what is called visual dimensions. And the visual dimensions in bar chart are these: the length or the count, which represent the frequency of the variable. We also have the category, which will be in the x-axis. The color is the one that identifies each of the species in your data set. Don't let me forget that this one here is what is called y-axis, and that also represents the number of times that those species appear in the data set. Another visuals that we can use to visualize our data set is what is known as histogram. A histogram is always used to visualize any continuous variable. For example, this is a histogram. The difference between a histogram and a bar chart is that in histogram, there is no space among the bin width in the histogram, while the bar chart has spaces among bars. As you can see here, you will see that the flipper length ranges from 172 to 230. You can see that the most flipper length ranges between 185 to 196. And what are the various components of a histogram? The first one is known as bin limit. And bin limit is just all this, as you can see here, is from, we have some intervals which are just 10, as you can see, from 170 to 180, from 180 to 190, from 190 to 200, and so on. You can see that each of the bar has like 10 widths or bin limits. Another component of a histogram is what is known as count or length, and this is what we have here in the y-axis. Then you can also use color, to beautify it better. Although the color there doesn't show anything, only that it beautifies your histogram. And if you compare your color with what is in the bar chart, you will see that the color, identify different species, because here we have many species. While in the histogram, color is just used to beautify it. Another visualization that we can use to represent our data is known as scatter plot. Some people also call it scatter diagram. What does it do? A scatter diagram shows a relationship between two variables. As you can see here, in this diagram here, we are showing the relationship between b depth and b length. And as you can see, these are the points, of each of the b depth and b length all together. A scatter diagram also has some components. The first component is known as x-axis, which will be displayed here. While the y-axis will be on this side here, sometimes you can call the x-axis horizontal axis, while the y-axis here is also known as vertical axis. You may also want to, display shape. For example, here you can see that each point is represented by a small circle. As you can see, there are many small circles here. Some people also use a plus sign to represent data points, and that is what shape is all about. As you can see here, I represent all these data points by using blue color. As you can see, here is a blue color, as you can see. And if you like, you can change the color to yellow. Whatever color you like is also possible to use. And you may also want to use size. But don't worry about all this. You will see all of them when we start using Seaborn to do it. Another chart that you can use to represent any categorical variable is called a pie chart. A pie chart is the sectorial representation of your data set. For example, as you can see Adeli here, so this sector represents Adeli, while another sector here represents chinstrap, while the remaining sector represents gentoo species. And one component of a pie chart is color. As you can see, we are separating each species by different color. For example, the blue color represents Adeli, while the green color represents chinstrap. The orange color represents gentoo. And one thing to note is that you don't use a pie chart when you have more than 5 different levels. As you can see, this one we have just 3 levels of species, and they are Adeli, chinstrap, and gentoo. Anytime that your level is more than 5, please don't use a pie chart. Instead, you can use a bar chart. Another visual that you can use to represent your categorical variable and a continuous variable is known as a box plot. Sometimes they call it box and whisker plot. What is box and whisker plot? A box and whisker plot represent variation among your categorical variable and a continuous variable. So which means that when you are using a box plot and you want to show how the categorical variable is related to a continuous variable, you may want to use a box plot to represent that. Now, let's see various components that is available for box and whisker plot. The first one is known as x-axis, as you can see it here. This is where you will put your categorical variable. And the other component is known as y-axis. This is where you will put your continuous variable. And let me explain it clearly. You can see that lily species has more sepal length than other species. As you can see, its own box plot is a little bit higher than the others, as you can see. Now let's see what are all these. The first thing here that you can see for every box plot here is known as the minimum value or the minimum point. While this line here is known as the first quarter. This middle one here that you can see here is known as the median data point. While this one here is known as the third quartile. While this is known as the maximum value of the data point. And sometimes there may be some outliers, which are these, as you can see here for Lily. There is also outlier for Rose, as you can see it here, outlier here. That is why whenever you want to examine whether there is a outlier in your data set, you may want to use box plot to show that. Let's see another visual, a line chart. What is a line chart? A line chart is used to see the trend in your data set. A line chart always have two variables. The first one will be the time variable, which you want to show according to the time. While the second one here, which is the y-axis, will be your continuous variable. You can also use color, to beautify it, as you can see. And the good thing about a line chart is that it will tell you whether there is a growth across the time. As you can see it here, this is COVID-19 in Nigeria. And as you can see that COVID-19 cases is increasing according to the time. As you can see, from February to March to April and so on, as you can see, it's just growing higher and higher and higher. You can also use size, which is the thickness of your line chart here. Now let's see various packages that are available for data visualization. In Python, there are many packages that are suitable for data visualization. The most common one is known as Matplotlib. Matplotlib is good whenever you want to visualize a quality data visualization. One good thing is that many advanced data visualization packages such as Seaborn, which we will see later, they are built on Matplotlib. So I will advise you to master Matplotlib. And this module will actually show you how to use some of the Matplotlib functions. Another package that is also available for data visualization is known as Seaborn. Seaborn is actually good when you are working with data frame and you want to plot one or two variables. Another data visualization that is also available in Python is known as Plotly. One good thing about Plotly package is that it's always good for interactive data visualization. Then we also have Pandas. As you know, you've been using Pandas since. We can also use some functions in Pandas to visualize our data. One good thing that I want you to note is that this module will only show you how to visualize your data by using Matplotlib and Seaborn. In summary, I have shown you many reasons why you must master data visualization. So let me represent all of that by using this diagram. As you can see, the first thing about data science is that you collect data and then you process your data by cleaning it, and then you start using different exploratory data analysis to visualize your data set. And in CS31, you will now use machine learning to build different models so that it can be good for prediction. Welcome to the practical session of data visualization. In this video, you will see how to visualize your dataset. Remember, before you start doing anything, you have to install various packages that will be useful in that project. So in this case, I will be importing NumPy, Pandas, Matplotlib and Seaborn because we'll be using Matplotlib and Seaborn all together in this video. So I run it. Now that we have loaded our packages, let's see how to import our datasets. In this case, I will be using a dataset called Food Service Tips dataset. This is data from Nairobi, Kenya, in which anyone that comes to the restaurant is giving those restaurant attendants a tip. You like tip, right? And let's see what you can get from this dataset. This dataset has various columns such as total bill, which is the cost of the meal in Kenya shilling. Tip, that is a gratuity in Kenya shilling. Gender, male or female. Smoker, whether the person that comes to the restaurant smoke during the meal or not. We also have day, which is the day of the week at which they do that party in the restaurant. And the time. Time is the time of the day, whether it is during the lunch or dinner. And size is the size of the party. So let's load that dataset. That dataset, as usual, is stored in the dataset folder. So I'm going to run it and save the result as tip dataset. Then you may want to see how the dataset looks like by calling head attribute. Now you can see how it is. You may also want to see the tail. These are all the exploratory data analysis. You can also see the columns, how many columns and what they look like. Remember in the previous video, I showed you how you can do all this automatically by using Pandas profiling. In that case, I will importing Pandas profiling by using from Pandas profiling import profile report. And that is what I just did here. And remember, we will be taking a function or an attribute called profile report. So I will be calling profile report on the tips data. So if I run it now, I will get various data exploratory on this data set. I'm still waiting for it. I'm still waiting. Now I have the result. As you can see, we have a lot of reports such as overview, the variables that are there, and their visualization. As you can see all of that. Since you know how to work with Pandas profiling, I will not spend more time on this. In this video, we will be using Seaborn and Matplotlib together. And at times, you may want to set the themes of that Seaborn. So Seaborn has several themes such as dark grid, white grid, dark, white, and ticks. I prefer white grid. I am using sns.setStyle to set it. Remember when we were importing the Seaborn package, we used Seaborn as SNS. SNS is the alias for Seaborn package, while plt is a alias for matplotlib.pyplot package. I hope you get it. Thank you. So let me go back to where I was. Now we'll be using various Seaborn attributes to plot our data set. So the first thing is, how do we plot a scatter diagram? Remember in the last video, I showed you what scatter plot looks like. Remember, when you are plotting scatter diagram, you must specify your x-axis and your y-axis. And Seaborn will also help you to do that. For example, we will call sns.redplot. Redplot is for scatter plot in Seaborn. And we will specify our x-axis and our y-axis. Imagine here I say x is equal to total bill. Total bill is a variable of my data frame, and you have to put everything in quotation since that is a string. Remember, we also have y, so you specify your y-axis. In this case, my y-axis is here, while my x-axis is here. For my y-axis, I will put tips because tips is what I want to put in my y-axis. Then there is one argument in Seaborn called data, and that is where you will specify the data frame that you want to use for this data visualization. So if you run this now, you get this plot called scatter diagram. Now you can see the relationship between a tip and total bill. Now you can see that here there is a positive relationship between tip and total bill. What does that mean? It means that when the bill increases, then the tip will also increase. Now let me show you how I did it again. So I call CNS. CNS is the Seaborn module, and the function of Seaborn that will help us plot scatter diagram is called relplot. RELPLOT. Alright, and you specify your x-axis, you put the variable there, you specify your y-axis, you put the variable there, and you also say that data is equal to, data is an argument in which you put your data frame into. Now I have the result as this. Isn't that interesting? You can see it looks good, doesn't take more time, and it's very easy to understand. One of the good things in data visualization is the ability to change the axis name, either the x-axis, the y-axis, the title, and all of that. So we'll be using Matplotlib functions to do that. And for example, to change the x-axis, let's say you want to change the name, you can use plt.xlabel, and you specify the name that you want to put to it. For y-axis as well, you will use plt.ylabel, and to change the title as well, you will use plt.title, and plt is taken from Matplotlib package. Now let's see how we can modify this so that we have a better axis name. So let's see it. So here I have the same thing, SNS red plot to plot my scatter diagram. I specify my x-axis, I specify my y-axis, and for the data, I put my data there, which is my imported data frame called tips data. And I'm changing the x-axis to be total bill for the mail, while the y-axis is changed to tips given in Kenya shilling. And also for the title, like I want to give it a better or a good title. Now I call it tips versus total bill. So if I run this now, you can see that I have everything well defined. I can easily read, oh, this is total bill for the meal, that is the amount of bill for that meal. And here is the amount of tips a particular person give after the meal. And you can see the title of our scatter diagram. Let's see important note. You can see that when you are visualizing it, you are seeing some unusual text, like something that is not meaningful to you. So to ignore that, we are going to put a semicolon after the last line of your code. So in this case, I'm putting the semicolon here. If I run it now, you can see that there is no comment again, and I can see my data visualization clearly. Let's see another plot. This plot is called scatter diagram, and in this case we are also putting a line under it which we call regression line. It's almost closer to what we have done here, but we want to show the line called regression line just to see the relationship between the two variables. And in that case, I will be using a function called lmplot. This lmplot is also from SNS or Seaborn package. So in that case, I will say sns.lmplot. I will also specify my x-axis, which is total bill, specify my y-axis, which is the tip, and call the data frame into data. Then you remember the semicolon here is to remove all the unwanted comments at the top of my figure. So if I run this now, as you can see now, I now have that line, which is called regression line. And one other thing about this is that you can see something like a gray line here, which is the confidence interval. If you want to remove that, you can just specify ci is equal to none. That is, don't give me any confidence interval. And in that case, I will have something like this. So if I run it, as you can see, there is no longer any confidence interval again, and we now have precise line under our scatter diagram or scatter plots. Let's see another example of visual that we can use to represent our data. In this case, I will be using what is called peer plot. Peer plot is, is trying to give us different plots that will be suitable for our data frame. And what that one takes is just your data frame. You don't need to specify your x-axis or your y-axis. What you need really is your data frame. And to use peer plot, you will call sns.peerplot like this, and you put your data frame inside it. Now if I run it now, as you can see, it's running. Now I have everything. Here is total bill, histogram. Here is total bill and tip, as you can see. This is tip and total bill. So you're just trying to, pair those plots together. All right. There's another plot called joint plot. What does it do? Joint plot is similar to that of scatter diagram. In that case, we want to show the scatter diagram alongside with every variable. So every variable will have a histogram. As you can see, here is a histogram, here's another histogram, and now we now see the scatter diagram which represents the two variables altogether. So let me run it. And to do that, you are going to call sns.jointplot. You will specify your x-axis, specify your y-axis, and your data frame, and then you run it. As you can see, now you can see the histogram of total bill, you can see the histogram of tip, and you can see their relationship. This is mostly common, when people want to show the relationship between two bivariate variables. They will just do something like this. This is important because you can see the individual distribution alongside with the scatter diagram. I hope this video is becoming more interesting to you. It's actually very easy. Let's continue. Another one that we can also see is histogram. Remember, a histogram is used to represent a continuous variable. Now let's see how we can plot a histogram. To plot a histogram, you will use a function called sns.histplot. In that case, you will now specify the column that you want. Remember, here we don't have y-axis. So what we are doing here is that we call our data frame, which is tips data, and we now call the column that we want to visualize In this case, it is total bill. All right, and you may just remove this. If I run this now, as you can see, I have the histogram like that, as you can see now. So what is it? Your x-axis, and you call the variable that you want from the data frame. So imagine I change this guy to tips, and let's see what will happen. So if I call tips on here, I will have this. Oh, I'm getting an error. Let's call it tip. Now you can see this is for tip, and I've shown you how that of total bill looks like. So here is total bill, and the histogram is like that. Sometimes you may also want to show the density distribution on that histogram, and this is how to do it. So what we do is to specify KDE equal to true. The first thing is to call the sns.isplot, call the x-axis and extract your variable into it, which is tips data, total bill, and then call the argument KDE equal to true. That is, give me the density plot of my histogram. And if I run it now, I now get the answer. As you can see now, I have the good output now. So let's see another one. In this case, I want to use what is called box and whisker plot. Remember, we can use box and whisker plot for continuous variable. In this case, I want to see the distribution of my total bill. Now, I have it y-axis, okay, and you call the data argument into it. So if I run it now, I have the box plot here. And you can see, as I said before, this is the minimum, this is the first quartile, this is the median, this is the second quartile, this is the third quartile, and this is the maximum. While all the points here represent the outlier, that is extreme values or unusual values in this variable total bill. For box plot, you just say sns.boxplot and you specify your y-axis and the dataset that you are going to use for plotting this. Sometimes you may want to show the box plot in an horizontal manner. In this case, you can just specify x-axis to be your variable. Remember, for the previous one, we have it in this case, we have y is equal to total bill. And then, because we want to show it horizontally, then we now change our y to x. Now, as you can see, it is now being plotted horizontally, while the previous one, which has the y-axis, is now represented vertically. You can actually do it either way. Welcome back. In this video, you will see how to plot categorical data by using some data visualizations. I will continue from using data visualization script, the one that you have here. In order to see it clearly, I'm going to close this folder so that you can see it clearly. Now, how do we plot a bar chart? We can plot a bar chart by using cant plot. The cant plot here will help us to visualize categorical data by using a bar chart. How do we do it? The first thing to do is to use sns.camplot, and then you will specify your x-axis, which is what we have here. And the x-axis here will take a variable called day. You then specify your data, that is your data frame, into the data argument like this, and you then have a bar chart like this. As you can see, this is a bar chart that represents the number of days that those people came to the restaurant. You can see Thursday, Sunday, Monday, Saturday, Wednesday, and so on. One thing you can notice in this bar chart is that the number of days are not in right order. As you can see, the first day of the week should be Sunday, but you can see it here, that we have it as Thursday. So count plot allows us to put it in the right context. In that case, I will have something like this. With the help of the order argument, I can then order my weekday in a list. As you can see, it's still the same plot that I have here. I have specified my x-axis to be my day, and then the order of this bar, as you can see. So I have it in this way: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And I put it in a list and put it under the order argument. And then I specify my data frame, which is tips data. And also relabel the x-axis by using plt.xlabel. And in that, I put day of the week so that people can see what this is all about. I also have my ylabel by using plt.ylabel as number of visitors, just to know the number of visitors that came to the restaurant per day of the week. Now, if I run this now, you will see that my order of the week is now in the right order. You can see Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And what you can deduce from this bar chart is that people usually visited the restaurant on Saturday. As you can see, Saturday has the highest bar with 160 visitors. That is all about count plot. Count plot allows us to plot categorical variable. Now let's see what bar plot is all about. You may be asking, what is the difference between a count plot and a bar plot? In Seaborn, there is a difference between this count plot and a bar plot, although they represent the same thing. But the difference between a count plot and a bar plot is that under the bar plot, you have to specify the y-axis. But in count plot, you don't need to specify the y-axis. Reason is that count plot will automatically display the frequency of that categorical variable for you. Now, before I go to the bar plot, let me show you what I'm talking about so that you can understand it clearly. I'm going to create a new cell under this place, or let me create it after this place so that you can get it clearly. I'm going to create a new cell in this place, and I will call my tips data my tips data. Okay, then from there, let me say day of the week. Okay, by using this, and I call the variable the column of this and call it like day. As you can see, day. So if I run it now, see what happens. I have several, Thursday, Sunday, and all of that. And to get the frequency table, remember I have to use value count. Just say value count, the one we saw in the last video. Okay, if I run this now, you can now see the day of the week and the number of visitors that attended that restaurant. And this is exactly what this bar plot is doing now. You can see that here we can specify our x-axis, and the y-axis will now be the total frequency for each day. But count plot has done that automatically for us, and that is the main reason why we will no longer specify y-axis in count plot. So now let me show you how the bar plot works. For the bar plot, we are still plotting the bar chart for the categorical variable, and in this case we are also using the y-axis under it. To use a bar plot, you are going to say sns.barplot. Then you now specify your x-axis. In this case, it is called smoker. The y-axis here is called total bill, and then you specify the data, which is our tips data frame. So let me run it. Now you can see that smokers here, you can see the smokers and the amount of total bill they pay during the restaurant or during the meal rather. Now you can see that those people that smoke, as you can see, they have more money, or let's say that they have more total bill compared to those people that did not smoke. That means that people that smoke, they paid a lot of money, maybe they ate a lot of food compared to those people that did not smoke during the meal. You can also see that we have a line here. So this line is called error bar. You may also want to remove it if it is not necessary for what you are doing. So to remove the error bar, you can specify ci is equal to none. The ci here means confidence interval. So if I put ci equal to none and I run it, I now have a bar chart that doesn't have any error bar. I hope you understand it, right? It's actually so simple. Let's see another example. In this example, I want to show you how to plot a pie chart. Remember that a pie chart is a sectorial representation of dataset, and that variable must be a categorical variable. So one thing is that we don't have a pie chart under the Seaborn. In that case, I will be employing Pandas data visualization to be able to plot a pie chart. Now let me explain how to do that for you. Remember that you can extract a variable from a data frame by using all this. Let's say I want to know the gender distribution. Okay, I can get it like this. I can see male, female, and all of that. And to have a frequency table, I can just say dot value count. Dot value count. As you can see, dot value count. Alright. So now if I run this now, I now have the frequency distribution by gender. Okay, so if I want to create a pie chart now, what I will do is to have something like plot. I can just say another function or another argument called plot. In that case, there is one argument there called kind, and I then say pie. Remember, for every data visualization, you must end it with a semicolon. So I'm putting it here now. If I run it now, see what I have. I now have a pie chart. In this case, I can see the sector for female. I can also see the sector for male. And that is how to draw a pie chart with a pandas. The reason why we cannot use Seaborn in this case is that there is no functionality for a pie chart with Seaborn for now. Now let's see another data visualization. In this case, I want to plot a box plot. Remember, in the continuous variable, we've seen how to use a box plot to represent our data. And when we also have a categorical variable with one continuous variable, we may want to use a box plot to show the variation among the levels of our categorical variable. And that is exactly what I want to do here. Now, to draw a box plot with Seaborn, you can use SNS.boxplot. And then your x-axis here will be your categorical variable. So in this case, it is smoker. And then we specify the y-axis. In this case, your y-axis will now be the continuous variable. So here I have what is called total bill. Then you will specify your data frame by using data is equal to tips underscore data. Then you run it. Now you can now see a box plot. So what is this box plot telling us? The box plot here is showing us that those people that smoke, as you can see, smokers, they pay more bill compared to those people that did not smoke. And that is exactly what this showed us before here, when we were seeing the smokers by the tip, as you can see. Another chart that we want to play with is called violin plot. Violin plot is also the same thing like a box plot. The difference between a violin plot and a box plot is that a violin plot always take care of the outlier, while box plot doesn't take care of outlier. It will show you where the outlier is, as you can see. So it means that a violin plot is robust to outlier, and that is how it looks like. As you can see here, you can see for gender, you can see for female, and you can see the total bill, and you can see how the violin shows those distribution. Before we complete this session, let's see how we can save our plot as an external file. To do that, we'll be using a Matplotlib function called plt.savefig. This will allow us to save our plot as an external file, and the external file may be in form of a PNG, a JPEG, or a PDF. So let me show you how to do that. Remember, in the previous session, I showed you how to use SNS count plot, which helps us to plot a bar chart, something like this, as you can see. And what this visualization is all about is that the number of size, okay, that came to the restaurant, for example, we have size 1, and this means that it's up to like 70. And for the size 2, it's more than 200. For the size 3, as you can see, this is the total size for size 3 and all of that. So let's say that you want to save this visual now as a PNG file. To do that, you have this to help you do it. Remember that in order to plot this, before you plot it, you have to at least have a good label. For example, people want to know what is this size all about, or the count all about, and that is why we are having this to help us. For example, the plt.xlabel helps us to save it as size of the party so that you can see the label here. And also, plt.ylabel allows us to rename this count as number of attendees. Now, let's say that after you have done that, you want to save this file. Let me first of all cut this and run it. So let's say this is my visual, as you can see. Now, in order to save this as an external file, I can then include this function there. And it is plt.savefig. Fig means figure, that is, we want to save this figure. And to do that, you have to name it. That is, the name you want to save your figure with. In this case, I'm calling it size.png. So this is the name of my figure. If I run it now, see what happens. I have my figure here, but something has happened. What happens is that if you look at my folder here, you can now see the file here. As you can see, the file is here, and I can easily open it. As you can see now, I can open it, and if I minimize my screen and open my snippet codes, as you can see, now I have the file here, which is as a result of what I have saved as an external file. If I open this now, as you can see, I now have my figure being opened without pandas or without anaconda, as you can see. And this now is useful in an external file. As you can see, I can open it, and I can open an MS Word like this, okay, and then copy it there. As you can see now, my MS Word is open, and then I can copy this guy by just right click on copy, and come over here, and then you can paste it. As you can see now it's being pasted, as you can see, okay. Then you can also, as a report, you can just say, let's say this is figure 1, okay. I can say the number of size, number of attendees, the number of attendees that came to the party. And exactly as you can see now. So this is how to save a figure from Seaborn. Okay, this is our figure as well. And let me go to my script. This is it. So let me show you another example before we close this video. Now let's say that I want to plot, let's say I have SNS dot let's say bar chart, bar plot, okay, and here I have x is equal to, let's say let me look at one figure, like let me just copy this and let me show you how I can save that as an external file. So let me open more cells, let me replace this. Okay, you can see now that if I run this, I have this. So let's say I want to save this. I can just come over here and say plt.savefig. Okay, and then I close the bracket and I call it a name. Here I can call it violin plot. As you can see, I can just say violin plot, violin plot, violin plot dot png. png is my extension. So if I run it now, you can see that I now have my violin plot being saved. So let's look for it. You can see now it's now dropped. This is the violin plot. And if you look at your folder here, you can see violin plot. This is it. And you can open it. As you can see, this is the violin plot. Thank you so much for watching this video. We have now come to the end of CS22. Remember that a programmer must practice every day. And to become a data scientist, you must practice. Read everything, practice every code, and make sure that you participate in the forum discussion and do your assignment. Thank you so much once again, and see you again. Bye bye.